Many accounts of intellectual history assume human knowledge evolved up a strict linear ladder. Myth organizes early thought, religion formalizes it, philosophy subjects it to reason, and science arrives to replace them all. This model is frequently struck through by the actual historical evidence. The historical record shows that sophisticated empirical practices often emerged and flourished while absolute religious cosmologies remained the dominant framework of a civilization. This cuneiform tablet demonstrates how Mesopotamian astronomers recorded celestial data centuries before the scientific revolution. They used these systematic rows to accumulate intergenerational observations, creating an externalized memory that allowed for mathematical prediction within a divinatory, sacred context. Science represents an organizational differentiation of knowledge rather than a replacement for what came before. It is a change in how specific claims are authorized, moving from external tradition toward testable evidence. Early human knowledge operated as an integrated package, a single cluster where nature, the gods, illness, and morality were not separated. Over time, this package expanded into a branching matrix of specialized domains. We see this integration in the 12th century Chahar Makala, which lists the 4 professions essential to a ruler. First, the secretary, then the poet, the astrologer-astronomer, and the physician. In the medieval court, these fields functioned as a single intellectual package, with no hard boundary between literature, administration, and natural investigation. Scientific differentiation occurs when a specific branch of this network acquires enough autonomy to establish its own standards of truth, regardless of the larger religious or philosophical framework surrounding it. To understand the origin of science, we have to look for the specific conditions that allowed knowledge to become detachable from the authority of the past. Early philosophy moved the axis of authority away from cosmic order and toward the reasoning individual. The central question changed from "what does the sacred tradition tell us?" to "what can I establish through rational demonstration?" This logic can be expressed as a formula. You begin with a premise, apply valid reasoning, and arrive at a conclusion. If the reasoning is valid, the conclusion is guaranteed to follow, but only if the original premise is true. This creates a fundamental limit. 2 philosophers can begin with different premises and use identical, valid reasoning to build entirely different models of reality. Because both are internally coherent, logic alone cannot determine which model nature actually follows. Conceptual coherence is not empirical confirmation. While reasoning is a necessary structure for science, it remains insufficient to describe the physical world. We can distinguish between 2 types of inquiry. Local questioning investigates problems within an accepted framework, while boundary questioning examines the validity of the framework itself. Mullah Sadra, a 17th century philosopher, provides a case study in these boundaries. He developed highly dynamic concepts like the primacy of existence, yet he worked within an absolute religious frame that he did not treat as a testable hypothesis. To evaluate the reliability of such a system, we can apply a subtraction test. If we remove the religious commitments, we can isolate the underlying philosophical core. When we subtract the theology from Sadra's concept of substantial motion, we are left with a coherent proposition that change can penetrate the very constitution of an entity. This idea remains logically defensible and independent of revelation. Brilliant philosophy can be conceptually compatible with science without being a scientific discovery. Until a philosophical claim is constrained by evidence, it remains within the realm of metaphysics. Ibn al-Haytham applied this constraint to optics. By studying the physical structure of the eye and the geometry of light, he turned the mechanism of seeing into an object of systematic experimentation. Analyzing the sensory apparatus itself forces a new admission. Human perception can be biased or mistaken. This means the statement, "I see X," is no longer an absolute authority. The observer's immediate experience must be questioned and corrected. Science introduces a mandate that goes beyond logic. It asks what observable consequences follow a claim, and crucially, what specific evidence would prove that claim wrong. Physical reality is not required to conform to our most persuasive arguments. In the scientific method, reason generates the possibilities, but empirical evidence constrains which of them are viable. Relying on the individual observer was a necessary transition, but an individual's data is limited and often distorted by their own perspective. This problem was addressed by externalizing the observer through physical instruments. These tools standardize measurement, allowing different people in different places to produce compatible evidence. This transition moves authority to the testing we. Individual measurements are aggregated, published, and subjected to collective criticism. The cognitive unit is no longer a single mind, it is the entire community. Institutional structures like the Royal Society and the Moraga Observatory transformed individual observations into a permanent, cumulative record. They created the first systems for circulating collective criticism. Science first empowers the individual to break from inherited authority, but then it constructs rigorous procedures to reduce dependence on any one individual's bias. We can now summarize the conditions for scientific differentiation into this single framework. Scientific progress, or Ds, is the product of 7 interacting variables: question openness, epistemic autonomy, systematic observation, measurement, testability, collective criticism, and institutional continuity. This cascade shows the specific transitions we have tracked. Each step, from narrative explanation to institutional self-correction, strengthens the ability of a community to revise its own knowledge. Science did not destroy philosophy. It incorporated the power of reason while binding it to the aggressive constraint of independently accessible reality. The history of science is a movement from authorized knowledge to questionable knowledge, from questionable knowledge to testable knowledge, and finally toward collectively corrigible knowledge.